Assalamualaikum, salam sejahtera, and greeting to the respected chair, distinguished delegates, fellow researchers, and students. It's my pleasure to present our work entitled Amendment of Dairy Farm Effluent Compost in Planting Media for Sustainable Oil Palm Nursery Practices. The African oil palm, or Ilex guinensis, is the world's most productive oil-yielding crop. It contributes about 40% of the global vegetable oil supply, which include the crude palm oil and palm kernel oil. In Malaysia alone, oil palm covers more than 5.6 million hectares and produces over 18 million tons of crude palm oil every year, contributing almost 25% to the global supply. Clearly, it's a vital crop, not just for our economy, but also for global food security. Oil palm's journey begins in the nursery. Germinated seeds are raised in polybag for about 12 to 14 months before they are transplanted to the field, where they can remain productive for 20 to 25 years. This early nursery stage is crucial. The quality of seedlings here directly affects uniformity, establishment, and ultimately yield potential in the field. While genetics are important, nursery management, especially growing media and nutrient supply, play a vital role in producing strong and resilient seedlings. Traditionally, nurseries rely on mineral fertilizers to sustain seedling growth. However, this practice raises environmental concerns such as nutrient leaching, greenhouse gas emission, and soil acidification. So there's an urgent need for sustainable alternatives. Organic amendments, particularly compost, are emerging as promising options. Studies have shown that compost derived from palm oil meal residues can improve soil properties. These include the physical, chemical, and biological properties, enhance nutrient retention, and support seedling growth. They can also enrich microbial diversity in nursery soil, further boosting nutrient cycling and seedling vigor. In short, compost not only reduces fertilizer dependence but also improves overall nursery sustainability. Despite of these benefits, we still lack of evidence on one particular organic amendment, which is dairy farm effluent compost. The compost is produced by composting celery, manure, and bedding materials from dairy farms. This compost is nutrient-rich and has the potential to reduce reliance on mineral fertilizers while also recycling farm waste, aligned with the circular economy principles. But its performance in oil palm nursery hasn't been fully evaluated. Therefore, this study set up to evaluate oil palm seedling growth and biomass accumulation when dairy farm effluent compost is amended to the nursery planting media, and to determine the mineral fertilizer rate as well. For this experiment, we used 3-month-old Tenera oil palm seedlings, that's the Dura piscifera crossing, at 3-leaf stage with uniform size. The seedlings were obtained from Ulu Dusun Agricultural Research Center in Sabah, Malaysia. We tested 4 treatments combining soil type and fertilizer rate. Seedlings were transplanted into black polybags, each filled either with 100% mineral soil, in this case we used Silabukan series, or 1-to-1 mixture of soil and dairy farm effluent compost, as in table 1 that will be shown in the next slide. For fertilizer, seedlings receive either the full recommended rate, half the rate, or no fertilizer at all, as in table 2 that also will be shown in the next slide. Other nursery management practices are in accordance with the MPOB standard practices. Data were collected 9 months after transplanting, when the seedling reached 1 year old. We measured the seedling height, ball circumference, and the number of fronds. At the end of the trial, destructive sampling was carried out to assess primary root number and dry weight of the frond, stem, and roots. For the statistical analysis, we used analysis of variance ANOVA to test for treatment effect, and separated means using Duncan's new multiple range test or DNMRT at the significant level of 5%. We also perform Pearson correlation analysis to examine relationship among growth variables. We had 4 treatments and 5 replications per treatment, yielded a total of 60 experimental units. The seedlings were arranged in a triangular spacing of 0.9 meter under a rain shelter facility at the faculty. The experimental units were arranged according to the completely randomized design. Watering was done twice daily and manual weeding when necessary. The full red mineral fertilizer followed standard nursery recommendations by MPOB. The half red is half of the standard nursery recommended red. The results: at 9 months after transplanting, the amendment of dairy farm effluent compost had a significant impact on seedling growth and biomass. Seedling in 100% mineral soil without fertilizer, which is our negative control, performed the poorest with plant height of 73 cm, ball circumference of 9 cm, and only 15 primary roots. When full red fertilizer was applied in mineral soil, the growth improved substantially. Plant height increased by 15%, ball circumference by 26%, and root numbers by 60%. But the real improvement came from adding dairy farm effluent compost. A 1:1 soil to dairy farm effluent compost mixture, even without fertilizer, pushed plant height close to 97 cm and ball circumference above 12 cm, outperforming conventional practice. Primary root numbers were similar to the fertilized treatment, around 23 to 24. When dairy farm effluent compost was combined with half-red fertilizer, there was no significant gain compared to dairy farm effluent compost alone. Frond numbers stayed consistent across treatments at 14 to 16, but frond biomass was significantly higher in dairy farm effluent compost amended seedlings, showing more vigorous growth. These findings align well with recent research showing that organic amendments, including compost, can match or even surpass conventional nursery practices. The improvement was associated to nutrient availability and overall enhancement in soil health. To put this in perspective, the oil palm seedlings are considered field ready at 12 months when they reach about 90 to 120 cm in height, with 12 to 16 fronds and 20 to 25 primary roots. In our study, the dairy farm effluent compost treatments produce seedlings that fit these benchmarks. This indicates the dairy farm effluent compost amended seedlings are physiologically mature and capable to withstanding field transplanting. The biomass data followed the same trend. The negative control produced the lowest total biomass, just 130 grams. Conventional practice improved this to 206 grams. Dairy farm effluent compost without fertilizer raised the biomass further to about 270 grams. Additional half rate of mineral fertilizer does not significantly improve the frond, stem, root, and total biomass. Fronds contributing the largest share of the biomass. This picture showing the physical appearance of the oil palm seedlings at 9 months after transplanting or at the age of 1 year. Correlation analysis revealed strong positive relationship between most growth and biomass parameters. For example, plant height correlated strongly with bole circumference, while stem dry weight showed very high correlation with frond, root, and total biomass. This confirmed the above and below ground traits work together to determine overall seedling vigor. So, how does dairy farm effluent compost work so well? Mechanistically, compost improves soil organic matter, water retention, and cation exchange capacity. It also stimulates beneficial microbes that enhance nutrient cycling and root growth. These processes lead directly to more biomass in fronds, stems, and roots. Exactly what we observe. Other studies confirm that organic amendments can improve soil quality and reduce fertilizer needs, supporting the sustainability of oil palm nursery practices. Key takeaways. To summarize, dairy farm effluent compost significantly improves seedling growth and biomass compared to the conventional practice. Dairy farm effluent compost alone was just as effective as dairy farm effluent compost plus half rate of fertilizer, highlighting its potential to reduce fertilizer dependency. Growth and biomass traits were strongly correlated, reinforcing their integrated role in seedling vigor. And importantly, dairy farm effluent compost aligns with broader sustainability goals by recycling waste into a valuable nursery resource. These are my social media and contact information. Thank you.